Today's show is sponsored by Fauna. Fauna is the data API for modern applications. As application architectures evolve to embrace cloud APIs and microservices, you need a database that is always correct, always fast, and always secure. But you don't want to spend valuable time managing your database. Fauna modernizes your OLTP infrastructure by providing a 100% operations-free database without compromising on the capabilities needed for building industrial-grade enterprise applications. Whether you're building new microservices or augmenting existing services applications, FaunaDB lets you simplify code, reduce costs, and ship faster. Fauna is a Jepsen-verified, globally distributed OLTP database delivered as an API that works with the programming language of your choice. To learn more, visit fauna.com/cloudcast to try it for free. That's fauna.com/cloudcast to learn more and try it for free.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are. Welcome back to the Cloudcast. We are coming to you live from the massive Cloudcast studios here in Raleigh, North Carolina. Hope everybody is doing well as we roll along into November of 2020. If you are listening to this, the U.S. election should be done. At least the polls are all done. I don't know if we'll have the counting done by the time you listen to this Wednesday morning or anytime after that. But, what that means is we don't know whether we'll have more certainty, more uncertainty in the United States. But one thing we do know in the cloud is that this is earnings season. So let's jump right into cloud news of the week because all three companies have, the big three cloud companies have announced their earnings and let's take a look at what happened, look at some comparisons and kind of look at some trends of what's going on. First off, we'll start with the largest one. Amazon's AWS group announced earnings of $11.6 billion for the quarter. So they are now around a $45 billion organization within Amazon, up 29%. So Amazon's numbers obviously continue to grow in terms of revenue. They are slowing down over the last 7-8 quarters in terms of revenue growth. Part of that obviously is the laws of big numbers. You can't grow at 70-80% on larger numbers, or at least it's much harder to do. But $11.6 billion, 29% growth. So still a very, very healthy business for AWS. And obviously reInvent coming up here just a couple of weeks. And that's going to be like about a 3-week long process. So we will have coverage of AWS. We will try and lump everything into one show as we do every year, but we'll do the best we can. Second, next largest in line would be Microsoft. Microsoft does not break out their Azure numbers, as we've talked about for a long time. So let me kind of put this into context for you. Their intelligent cloud business, which is kind of the umbrella in which they count Azure, was $13 billion for the quarter. The Azure business within that, which they don't break out the exact number, was up 48%. So continuing to see Azure grow, still perceived to be the number 2 provider in terms of cloud size and so forth. But healthy growth for Azure. And then finally, Google announced that they are going to finally start breaking out the GCP numbers. And I think they actually said they're going to go back and retroactively break out numbers. I believe that's right. Don't hold me to that. But they broke out their numbers for the quarter, $3.44 billion. They beat their expectation. They were up 45% year over year. So all three of them continuing to grow, as you would expect, especially with COVID. More and more people beginning to move applications into the cloud as they make it harder and harder to get into your data centers and do things face to face. So we expected this sort of growth. We will, we'll be covering reInvent here, as we mentioned. We will be covering kind of the wrap up of the year here in the next couple of weeks and all. So, and finally, as we wrap up, before we jump into this week's show, it is a very interesting show, but unfortunately, sort of a sad note. Our condolences go out to the family of Dan Kahn. Dan was the executive director when the CNCF got started. He was unfortunately passed away this past week, complications from cancer. Dan was somebody we had on the show. He was a friend, somebody that I knew and had a chance to work with one-on-one and in groups a number of times. He really was influential in helping to drive the CNCF, drive the popularity and awareness of Kubernetes and a lot of the other projects in the CNCF. So really an unfortunate incident. He was young, had a family, loved his family. And so, the CNCF community and everybody who who follow that space is sad this time. So our condolences to Dan's family and his kids. And, if you have a chance, reach out on Twitter and share a story from Dan. He was a big personality, and he will be sadly missed. So with that, we will get on to our show. We have a very interesting conversation, sort of the third in a series of things looking at what's going on around the Jamstack and GraphQL. And today we're going to talk about serverless databases. So I think you're really going to enjoy this one right after the break. Today's show is sponsored by Cloud Academy. Listen up, y'all. This is a great offer. With everyone using the same cloud platforms, winning and losing comes down to having the best talent to build products better and faster. Cloud Academy is the training platform of choice for Fortune 500 companies and thousands of tech professionals around the world. Thousands of video courses, learning paths, practical hands-on labs in real-world cloud environments, Cloud Academy has tools designed to help teams assess, build, and validate critical cloud skills. Most importantly, Cloud Academy stays agile, challenging you with new content, labs, and tons of features that ensure your skills stay relevant and everyone can level up. They cover everything from cloud certifications to DevOps to security to programming languages. You can get started now at cloudacademy.com. For a limited time, Cloudcast listeners can lock in 50% off the monthly price for life. Just put in the coupon code CLOUDCAST at checkout. It's a great way to pursue certifications or just build cloud expertise. Again, that's cloudacademy.com and use the coupon code CLOUDCAST to lock in 50% off the monthly price. Today's show is sponsored by Datadog, a cloud-scale monitoring platform that unifies metrics, logs, and traces from technologies like Istio, AppMesh, and Envoy. Plus, Datadog's Service Map automatically plots out the dependencies in your microservices architectures for seamless, context-rich troubleshooting. With rich visualizations, algorithmic alerting, and more than 250 vendor-supported integrations, Datadog allows you to monitor your distributed applications in real time. Start a free 14-day trial today by visiting datadog.com/cloudcast, and Datadog will send you a great free t-shirt. That's datadog.com/cloudcast. And we're back. And folks, if you've been paying attention for the last couple of weeks or the last maybe month and a half or so, we've really been digging into some of these newer types of application stacks and application architectures. And so, we covered GraphQL a few weeks ago. We had a chance to really dig into the Jamstack here recently. And one of the things that we've been kind of lacking is, okay, these architectures, obviously, we're all kind of dealing with them in various places. Sometimes, it's an application that you love, but what about the data side of things? And so we thought, okay, we need to really dig into how do we, where is the data element in all this? Where is the database? Where is the data and so forth? So we thought, let's go dig into that with the folks that are really kind of reshaping what this looks like. So very excited to have Evan Weaver, who is co-founder and CTO of Fauna, join us today. Evan, thanks for being on the show.
Hey, thank you. How's it going?
Good. It's good. So you've been around a lot of interesting tech in your career, especially in the last few years, even prior to Fauna. Give folks a little bit of your background as to what some of the things that you have worked on in the past, and then what sort of motivated you to create Fauna.
Yeah, so I in grad school I studied bioinformatics. I never did that again, but one outgrowth of that was I had a bunch of data that I needed to put online, and I had no idea how to do it. And that was sort of my introduction to web development. Initially I used Perl. I thought Perl was pretty cool. I still do, even though no one else likes it. But I got into Rails, in an effort to put the chicken genome work I was working on, on a dynamic web page. And I watched the Rails screencast, just like Rails 0.8. This was like 2005, back in the dark ages, before we had the cloud. And I got super excited because, Rails showed me that dynamic data on the web was possible. And then I spent a week installing Postgres. And that basically doomed me to working on data, especially scalable data, for the rest of my career. And I took that Rails and database experience. I moved more to the MySQL side of the house. I ended up liking MySQL better because it was more predictable at scale, even though, it was less featureful at the time. They were both less featureful, which we can talk about later. Went to CNET Networks. I worked on chow.com, which was a recipe site, and Urban Baby, which was a real-time threaded web chat for moms, which has some commonality with a real-time threaded web chat I worked on for everybody a little bit later. I worked on those products with the team that went on to found GitHub. And when Chris and PJ left to go to GitHub, I went to Twitter. And I was employee 15 at Twitter. And I ended up running what we called the infrastructure team, the backend engineering team there. And we built all the core distributed storage for Twitter.com, tweets, timelines, user storage, image storage, the cache, other storage. I'm sure I forget. The social graph was an important one. And, Fauna kind of grew out of that experience. We looked at SQL systems. We did a lot of work in MySQL. We did a lot of work with Redis. We did a lot of work with Memcache. We did a lot of work with Cassandra. We looked at NoSQL systems too. We looked at Mongo, but chose not to use it. And, basically we couldn't find anything at Twitter that would let us keep focus on the product. I had a lot of database and performance experience and a lot of Rails experience, but I wasn't like a database engineer or even a distributed systems expert when I joined Twitter. Part of the premise of Fauna grew out of that experience. We wanted to build a platform, a data platform in particular, that would let small teams, the way we were at Twitter when we were just 5 or 6 engineers, build and scale a consumer or business product, a SaaS product, to global scale without having to re-architect things constantly.
Yeah, no, makes sense. You mentioned, sort of the dark days of 2008 and things before the web. Folks, if for the older-ish crowd, you probably remember, if you were on Twitter, the concept of fail whale. I'm sure you remember it, unfortunately, too well, living through those days. And
the first thing I did when I joined Twitter was so Apache had no timeout. The browser, like if MySQL was slow, because there was a single MySQL primary, there were no replicas of any kind, no replication, very few indexes, basically no optimization. So when MySQL was slow, which was like every day, your browser would time out Twitter.com. And show you a white page after 5 minutes. I was like, well, this doesn't make any sense. The database is dead. Like, we should time out the web browser. So I added a 30-second timeout to Apache. 30 seconds is a tremendous amount of time, by the way, to time out a web page, but it made sense then. It was a big improvement over 5 minutes. And we had to have something to show when the timeout was triggered. So my colleague, Britt Salvatel, and I, we looked in the public images folder of the website, which happened to have some stock art, including the fail whale and the robot image that was used for the 500 error for quite a while. And we thought that the whale made sense to show for this timeout page. So we added the HTML. I wrote the too many tweets copy, so to speak, for the page. And that was history, I guess. I spent the rest of my career there fighting that whale.
Yeah, no, it's crazy. I don't want to go down a history path, although I was listening to something yesterday where somebody had gone back to the launch of one of the iPhones, and Steve Jobs was showing off 3G, and he was like, "Hey, look, here's a web page loading in 30 seconds." And he was like, "It is," what was the word he used? Snappy, I think was the word he used. So yeah, back in the day, 30 seconds wasn't unacceptable. So,
well, I mean, the history is important because history repeats and it informs what we're doing today. Like I think one of the things driving Fauna, Fauna is still the vision has never changed. We want to build that transparent and seamless and global data platform, data API that lets people, like us, not have to think about the operational data tier of the products they're building. But a lot has changed since the Twitter days. Like, Web 2.0 was new at the time. Twitter.com was basically a text area on an HTML page with rounded corners, and
right.
We shipped it on a single server, and like we had a startup. You can't do that anymore. You have to build, a very mature and polished product. You have to ship on the web with a responsive web app. You have to support multiple mobile platforms, and this continual rise in entry requirements to bring a consumer or SaaS product to market is one of the things that really pulls the industry forward. Because as those maturity requirements grow, the need for productivity grows as well. And if you can't get to market with the old tools, then it doesn't matter, what enterprise integrations they have or how scalable they are, any of that stuff, because it's just too much work to build. And that's one of the things in the history of our industry that has created this refresh and innovation cycle where the old technology and the old stacks get thrown out in favor of new technology which is immature but lets you get to market in a transformatively faster way.
Exactly. Well, and like you said, we sort of get to build on the shoulders of those that has a lot of scrapes and scars and learned lessons the hard way, and now can turn it into stuff that's easily consumable. I said in the introduction that we've on the show, just coincidentally, we've been covering some of the newer kind of architectures, kind of the new way that people are building the web, and some things that involve, mobile apps and so forth. I want to dig into the data side of things, because that's really where Fauna is focused, where you guys shine. There's a great link I'll put in the show notes for sort of what you guys call fourth generation application model, or client-serverless. Talk to us a little bit about kind of what this next evolution looks like, and really what's the role of databases and data APIs. Maybe just looking at it from third generation, we all know sort of end tier to where we're getting towards today.
Yeah, so we started building Fauna, like prototyping, like 4 or 5 years ago. We were a consulting company after me and my co-founder left Twitter for about 3 or 4 years, and then moved into product development. And we always wanted Fauna to be a serverless data API, but we were too early to market. Serverless was a joke. No one was really using Lambda or any of the Jamstack technologies in a serious way at all. Similar to when the cloud was new, people were like, "Oh, like how dare, it's unthinkable that someone else would operate your computer. Surely they cannot plug it in with the certainty and expertise that you can." So we found that, although this vision was real and it was shared by others in the industry, the tooling wasn't really there, and the rest of the ecosystem, or the rest of the stack, wasn't there to make it a productive development experience. But over the last couple of years, as we've been maturing the product, and as our peers and partners in the ecosystem have been maturing their product, we found both a set of technologies have come into play and been integrated in a relatively seamless way. And they've engendered a new architecture and a new way of developing applications, which is broader than just like specific Jamstack technologies or that kind of thing. And that's what we mean by client-serverless, because it's a return to a model we had in the 90s, especially the early 90s, but now updated for a global, more consumer-oriented audience. So it's part of like the consumerization of IT. It's part of work from home life now, especially. Like the application development model. In the 90s, like you sat in an office, you were in a cubicle, you had a PC, it ran like a MS Access application that talked to a SQL server in a closet somewhere.
Right.
Like there wasn't an application server in that path. And when we got the web, we threw out these rich clients. You couldn't carry around a PC and a CRT. Laptops were slow. Mobile web was barely existent. Cross-platform development was hard. So we pushed presentation and business logic as close to the database as possible, and we just suffered the latency from that 3-tier stack to wherever the client was. And that gave us technologies like LAMP initially, and then kind of the agile revolution and object-oriented web development with Rails and Hibernate and J2EE and technologies like that in the O's. Now that model worked really well for a while, but as clients got more powerful, in particular, browsers with initially Ajax, if you remember when that was like new and thrilling, and now like the full power of the JavaScript runtimes that are highly optimized, and the upgrades to ECMAScript and that kind of thing that have turned the browser into a full-featured, essentially, operating system for apps, as well as mobile phones, and the multi-core power you can get in your hand now has returned us to that world where we have rich clients all around us, but they're now global. So the challenge now is that they're not in a single site with a low latency link to the backend services. They're globally distributed over high latency, variable bandwidth, variable reliability links, and untrusted links. So we need data services and backend services which are built native for that web-oriented global world, but it's still the client server model. So what we mean by client serverless is this return to these rich clients that can do a lot of work where you are, which helps reduce latency, especially in global applications. But now they have to talk to global serverless APIs instead of single site infrastructure products installed from a CD-ROM or whatever, talking over a trusted link inside a VPN.
Yeah, no, it is. It's like, it's interesting. It's like you said, history tends to repeat itself, and we are coming back to this. Like you said, we're getting back to, we see distributed, we see centralized, we see distributed. Now we're back to having more intelligent sort of clients. And so the need for being able to just talk directly to the data becomes, again, more relevant, but then it just changes the problems we're trying to solve for. So
yeah, it wipes out this operational overhead,
right,
of having to manage, the application side infrastructure, the back end infrastructure.
Yeah. So help me understand. And like I said, in that article that you guys have on your website, there's some really good visuals. But data is obviously still stored somewhere, right? It's it's offered now as a service, so it lives behind an API. Kind of for somebody trying to wrap their head around when you talk about a serverless data API, like what is Fauna? Is it a database? Is it sort of an API service that is providing a bunch of the sort of the things you need for authentication and so forth? Or like, kind of try and explain to us how you explain what it does. It's because people sometimes, as you move from one generation to the next, sort of go like, okay, I know what a database is, I know what an API is, even GraphQL starts to change that whole model of what it looks like. So explain to us how you explain this to people so they kind of grasp what this new world looks like.
So Fauna is a data API or a database as a utility. Mm-hmm. It's solving the same operational data problems that something like a Postgres or a MySQL or a Mongo would solve. Mm-hmm. It's transactional, mission critical, short request business data, stuff that basically if you're building a product, the operational database is the foundation of that product's house, so to speak.
Right.
And so it gives you all the stuff you would expect from, especially if you've worked with a modern ORM or you've worked with something like Mongo. It gives you all the stuff you would expect from those transactional, user-oriented data interaction patterns. But what it also gives you is transparent, global, secure, web-native access. So you're no longer like provisioning a managed cluster in some cloud that lives in a specific place. You're really just instantiating a dynamic tenancy context in Fauna Cloud, which runs across AWS and GCP and is globally distributed. And you don't have to scale or manage anything because all the isolation is dynamic. So you get the same development capabilities, but none of the operational overhead. And that lets you now, you have an operational data tool. You have an operational data tool, which you can integrate in the same way you integrate your other backend APIs or your cloud APIs like Twilio and Stripe and what have you. Things that you used to compose in the application server, like in Rails or something, running on a VM. You're now composing from the client, or potentially from AWS Lambda or another piece of middleware like that. And you need a database that delivers the data capability and those data features, where you put your own data and not just how you interact with these other services in a way which mirrors those development patterns. Otherwise, you're just pushed right back into the 3-tier managed cloud full stack backend development world, and you lose all the benefit of the client serverless model.
Right. Gotcha. Now, as you're talking to people, both in the kind of the community around Fauna or potential customers and so forth, is your conversation tend to be with application development teams who are were previously responsible for we go and get data to interact with the application, or are you talking to former DBAs? Like, transitionally, how are people understanding kind of working in this new environment? If they had previously been kind of like you were at you were at Twitter early on, like, hey, I'm having to deal with SQL. What's that typical transition path? Who tends to lead it?
So we see two trends that sort of meet in the middle at the same point. We see front end oriented developers who are now becoming responsible for full stack application and full stack product development. And they say, I know these front end technologies. I don't know much or have much interest in understanding the managed cloud backend stuff. I want a database, which can let me add dynamicism to the utility computing serverless, Jamstack or what have you model that I'm familiar with working in. And, they typically use React.js, Next.js, Vue, other derivatives as a front end framework, and equivalents on mobile, whether they're native or transpiled. They typically use GraphQL as sort of in some ways a replacement for SQL, and if you'll forgive me, like also a replacement for things like SOAP and REST in terms of a common API protocol that lets them easily integrate, their various data sources and services. And they're looking to increase the sophistication of the applications they're building, from static marketing sites to things that have been, minimally augmented, like things that use a headless CMS, for example. Now there's some dynamic data, into full-blown, user-oriented dynamic applications. So they're coming at it from that side of the industry as they take on more responsibility within their building new products or within existing companies trying to extend products. At the same time, we see people, both operators and back-end and infrastructure engineers, they're facing some of the same productivity barriers I mentioned earlier. And they understand, how to optimize Postgres. They know how to work with managed cloud software. Like, they can do it all, but they just don't want to because it's not proprietary to their business. And they're looking to escape the operational burden of managed and on-premise databases without giving up the productivity or the capability that they're accustomed to from those more mature solutions. So where they would have rejected things like Redis and Mongo, for example, now Fauna can deliver the transactionality and the resiliency and the consistency that they're accustomed to without any of the operational overhead. So then, as compliance allows, and other internal concerns, they're starting to move existing and new data into Fauna. And that means, we're sort of ending up in this overlap position where they kind of all crash together in, a hybrid or transitional state where there's legacy data that lives on-prem or in managed cloud. There's middleware, old and new, and application services written, maybe deployed to Lambda now instead of deployed to EC2 directly, which are composing this data. There's front-end applications, mostly built in React, which are consuming this data, but also need to augment it and inject new data into sort of this overall ecosystem, and maybe talking to the database and the APIs directly as opposed to via something like Lambda, which intermediates the front end and the back end. And this whole mess is, from our perspective, a very, very clear indication of this trend towards utility computing in a very pure sense.
Yeah,
where the operational overhead has been fully abstracted by the cloud vendors, including us.
Right. Well, and I think it's Everything is a little bit evolutional in pockets, right? So like I imagine, 10 years ago when AWS first came out with, say, RDS, and they said, here's the value proposition. Don't worry about it. We'll be your DBA. It took a while for people to really kind of get comfortable with that idea because they had, a decade plus of, kind of like you said, it was important. It was proprietary to what they did, but also just, I feel comfortable when I have my hands on the controls and I can turn knobs and do things. But we're now a decade into people just saying, yeah, I could run the database, but I don't want to. And so I imagine there's a certain amount of that confidence now that helps you guys when you say, look, it's not just that we run the database, but it is sort of in this serverless NoOps model now. And people kind of trust that, I would assume, or they're more trusting of it than they may have been 5-10 years ago.
Yeah, that's totally true. And operational data is always the last thing to change because it's the riskiest, which is why we're still dealing with SQL, especially on the operational side. I mean, it's a good language for analytics, but it's still the visual basic of query languages. Like there's no consistency whatsoever, or composability, or security model, or performance model, or scalability model, or anything. But it's easy to get started with, and a lot of people are familiar with it. Like we haven't had a lot of fundamental change there. The move to this model and the need for web native interaction is finally driving a lot of that change with things like GraphQL. But I think from an operational perspective, people say they want control, but what they really want is transparency and trust. And like you mentioned, it's the same process that Amazon went through. I mean, like when Amazon first released EC2, they did beat on people's doors to convince them that they should move any workload at all, no matter how trivial,
right,
off of a physical server, or like at best, a VMware instance that virtualized a bunch of Windows boxes in a closet into the cloud. Like I can't see it. I can't go there and push the button or plug in like my serial cable for my terminal. Like, what am I going to do if it doesn't work? Well, you're going to get a new one. What do you mean get a new one? Yeah, that takes a year. Well, you can get a new one in an hour. Like, well, we have no concept of this. Like, and Twitter was the same too with the Twitter API. Like people don't remember now, but Twitter was one of the first APIs that really kind of gave away the keys to the kingdom and made all the business data and the product data accessible to anyone who wanted to interact. And thought that was crazy. Like, how could you give away something so valuable? What about bad actors? And that pressure actually kind of knocked Twitter off the track, in my opinion, especially in hindsight. And Twitter, backtracked on the investment in building that API, and focused on becoming more of a consumer product than a social infrastructure service, which was kind of the other the path not taken for Twitter as a business. But yeah, I mean, we saw the same thing. Serverless was a joke until about a year and a half ago or so. Then all of a sudden, it became legitimate but bad, if you know what I mean.
Right.
People like, well, fine, you have a point, but what about all these things? It will never mature. It will never have my my Lotus Notes integration. Well, nobody cares about that until the basic patterns of higher productivity have been laid down. So that's where we are right now. The industry is growing very, very quickly, but hasn't hit those maturity thresholds yet.
Right.
To have the credibility it needs in the enterprise, so-called. But obviously it's happening. It happened with the mean stack. It happened with the Rails stack. It happened with the LAMP stack. It happened with SQL Server and the client server stacks before that. It's always the same pattern.
Yeah. It's Steve Ballmer laughing at the iPhone because it doesn't have a keyboard, and it'll never get adopted. So, yep. Hey, one last question before we wrap up, and I let you go. And again, thank you so much for the time. You mentioned early on you had seen kind of one of the early Rails demonstrations, right? Lots of people did. I think it was like Rails for Zombie or Ruby's for Zombie. That was their way of learning that stuff. Is there a kind of a canonical Jamstack, Fauna kind of thing somebody can walk through today? Like, what's an easy way for somebody to kind of get that same moment you had with say, Rails, these days? Is there an easy way for them to kind of just get started and see something and be like, oh man, that's like, I really want to get passionate about this?
Yeah, I mean the typical stack is like Next.js and Fauna deployed to something like Vercel or Netlify. That's kind of like the pure front end oriented version of this experience. The best tutorial we have is the stuff on our website right now. You can interact with Fauna directly without having to use these other technologies out of the gate, and you can use the web console. Instantly provision a database, start inserting data, making queries. You can use the CLI, and then you can grab the JavaScript driver and go. We definitely have work to do in terms of, kind of mimicking that Rails 5 minutes to enlightenment experience. But the best way to start right now, I think, is to just sign up on fauna.com and start playing around in the web dashboard.
Yeah, very cool. We will get that in the show notes for folks. Evan, thank you so much for the time today. Like we said, there's times when we get to talk to really smart folks who are building these things, and we appreciate you educating us a little bit this morning. So, folks, with that, we're going to wrap it up today. I hope you're enjoying us digging into some of these new architectures. I know you guys always love hearing about what's coming next. With that, we're going to wrap up. Thank you, as always, for listening. Thanks for telling a friend. Thanks for helping to help us share the show and grow the show and give us feedback on things like iTunes and others. So with that, we'll wrap up, and we will talk to you next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.